Greetings, everyone. Welcome to today's presentation. Data deduplication is a data compression technique used to eliminate redundant copies of data, thereby reducing the amount of storage space required. This process ensures that only unique instances of data are stored, while duplicates are replaced with references or pointers to the original data. Deduplication can occur at various levels, such as file level or block level, depending on the granularity of the data being analyzed. There are two levels of deduplication. 1. File-level deduplication compares entire files and removes duplicates, useful in environments where identical files are frequently saved. 2. Block-level deduplication breaks files into smaller blocks and removes duplicate blocks, more granular and effective than file-level deduplication, especially for large datasets with minor differences. Data deduplication works by identifying and eliminating redundant copies of data, ensuring that only unique instances are stored. Here's a simplified explanation of how the process typically works. 1. Data chunking. The data is divided into smaller chunks or segments. This can be done using fixed-size chunks or variable-size chunks, depending on the deduplication method. 2. Hashing. Each chunk is processed through a hashing algorithm to generate a unique identifier called a hash value or fingerprint. This identifier represents the content of the chunk. 3. Comparison. The hash value of each chunk is compared against a database of existing hash values. If the hash value is not found in the database, the chunk is unique and needs to be stored. If the hash value already exists, it indicates that the chunk is a duplicate. 4. Storage. New chunks with unique hash values are stored in the storage system. Their hash values are added to the database for future comparisons. Instead of storing duplicate chunks, references or pointers to the already stored unique chunks are created. 5. Metadata management. Metadata is maintained to keep track of the references and the structure of the original data. This allows the system to reconstruct the original data when needed. Listed below are some benefits of using deduplication. Storage efficiency significantly reduces the amount of storage space required by eliminating redundant data. Cost savings lowers storage infrastructure costs by maximizing the use of existing storage resources. Improved backup and recovery speeds up backup and recovery processes by reducing the amount of data that needs to be transferred and stored. Enhanced data management simplifies data management by reducing the volume of data to be handled. Data deduplication is a powerful technique for optimizing storage efficiency and reducing costs by eliminating redundant copies of data. By storing only unique instances and replacing duplicates with references, deduplication significantly decreases the storage footprint and enhances data management. Despite the challenges of implementation and potential impact on system performance, the benefits of deduplication make it an essential component of modern data storage strategies. Compression in storage is a technique used to reduce the size of data by encoding it more efficiently. This process helps to save storage space, reduce costs, and improve data transfer speeds. Compression can be applied to various types of data, including text, images, audio, and video, and is commonly used in both file storage and data transmission. 1. Lossless compression reduces the size of data without losing any information. The original data can be perfectly reconstructed from the compressed data. It is used for text documents, executable files, and any data where integrity and exact replication are critical. For examples, zip files, PNG images, and FLAC audio files. 2. Lossy compression reduces the size of data by removing some of the information, which may result in a loss of quality. The original data cannot be perfectly reconstructed. It is used for multimedia files where a reduction in quality is acceptable for significant space savings, such as photos, music, and videos. For examples, JPEG images, MP3 audio files, and MPEG video files. Lossy compression cannot be used in storage because the file cannot be restored to its original form. Data compression works by encoding and decoding data, ensuring that lossless data compression compresses without any loss of data quality, and that the decompressed file is an exact copy of the original file. Here's a simplified explanation of how the process typically works. 1. Data analysis. Analyze the data to identify patterns, repetitions, and redundancies. 2. Encoding. Apply an algorithm to replace repetitive elements with shorter representations. Common algorithms include Huffman coding, LZW Lempel-Ziv-Welch, and RLE run-length encoding. 3. Storage or transmission. Store or transmit the compressed data along with a dictionary or key for decompression. Listed below are some benefits of using compression. Section storage efficiency. Reduces the amount of storage space required for data. Section cost savings. Lowers storage infrastructure costs and reduces data transfer expenses. Section faster data transfer. Compressed data takes less time to transmit over networks, improving performance. Section improved backup and recovery. Smaller backup files speed up backup and recovery processes. Data compression is a powerful technique for optimizing storage and transmission efficiency. By encoding data more efficiently, compression reduces storage space requirements and improves data transfer speeds. When setting capacity savings goals for data reduction methods, you must consider the following deterministic factors that affect deduplication and compression efficiency ratios, which are critical to storage performance. Section data type. It plays a key role in determining the degree of deduplication or compression. Snapshots, such as in VDI environments, are expected to provide higher capacity optimization rates. For databases, there is already a certain level of redundancy elimination at the application level. Therefore, the database may not generate significant savings through deduplication and compression. Section data change rate. The less data changes, the easier and faster it is to perform deduplication and compression. Each change made to data and saved to disk requires a separate check cycle to identify duplicate data sets and perform compression algorithms. This subsequently increases server overhead. Section data backup frequency. Especially in the case of full backup, the higher the backup frequency, the more redundant data will be generated. This will save more space during deduplication and compression. The efficiency of the data reduction can be measured as the ratio of original data size to reduced data size. For example, when the deduplication ratio is 10:1, 100 GB of original data only requires 10 GB of storage capacity, thus saving 90% of space. The higher the ratio, the greater the capacity savings. This depends on the ability of software to perform deduplication and compression, as well as the other factors mentioned above. These are critical stages in the data reduction process, allowing the engine to reduce the data footprint on storage. It applies these stages inline and dynamically. Each algorithm in the data reduction function is discussed below. 1. Zero block elimination. During the initial phase, any block consisting entirely of zeros will be identified and recorded in the metadata only. At this stage, the process only allows data containing non-all zeros to be filtered to the next processing stage. 2. Deduplication. In the second phase, incoming data is processed to determine if it is redundant, data that has been previously written. The redundancy of this data is checked through metadata maintained by the deduplication service core module provided as part of the data reduction engine. Any data blocks found to be redundant will not be written out. Instead, the metadata will be updated to point to the original copy of the chunk already stored on the media. 3. Compression. After the initial zero elimination and deduplication phases are complete, compression is applied to individual data. The compressed data is then packed into fixed-length chunks and stored on the media. This also speeds up the performance of reading data from storage, since a single physical block can contain many compressed blocks. It is very easy to install and implement. Please enter Maintenance, License page. Make sure enable Dedup license first. After that, let's create Dedup pool. Enter Storage page and then select Dedup and Compression pool. Select SSD drives for pool creation. Please notice that it is necessary to use full SSDs in Dedup pool. Once Dedup pool and file volume has been created, you can see here Dedup pool will have a Dedup label showing in GUI, and you can also see Dedup benefit how many capacity has saved in this page. First, this feature is license required. Please contact with our sales for more detailed information. In overall QSAN models, this function is supported on Xcube and NXT so far, and will also support on XCubeFast in the next stage. As mentioned, it is necessary to use full SSDs in Dedup pool. If involve any non-SSD drives, then dedup pool will not be allowed to create. Data reduction is a vital strategy in data management, enabling organizations to handle increasing data volumes more effectively. By implementing techniques like deduplication and compression, organizations can achieve significant cost savings, improve performance, and optimize their storage infrastructure. This holistic approach ensures that data storage remains efficient and manageable in the face of growing data demands.